here's integrated 3. It's 11.1.1 lecture part 2. So we're learning about how to simplify rational functions by using giant 1. So in 11-5, it says, work with your team to simplify each rational expression below, showing any ones, so the giant ones. Verify that your simplified expressions are correct by substituting values of x. For each expression, assume the denominator is not equal to 0. I don't think I'm going to keep substituting values of x anymore because my video will be too long if I keep doing that. But basically, you should know by now, I hope that you know, that you cannot just look at this and say, oh, look, there's an x squared and an x squared, I'll cancel those out. You cannot do that. You have to have factors. So in other words, you have to have something times something, and then they need to be multiplied together, not added or subtracted from each other in order to make a giant one. So like this right here, if I factor this, and I hope that you guys know how to factor, I look for something that multiplies to make 9 and adds to make 6. This is how I do mine. I call it a diamond problem. I want it to multiply to make 9 and add to make 6. So I think, what numbers multiply to make 9? Well, 3 times 3, and those also add to make 6. So I know, and then I can take a shortcut because this is just, in front of the x squared, it's just a 1. So I know it's just going to be x plus 3 times x plus 3. That's what this factors to. This down here is a difference of squares. So this just follows the pattern a plus b times a minus b. So this is x plus 3 and x minus 3. And this right here is what we call a giant 1. And maybe if you weren't in a CPM class before you got here, that's supposed to be a 1, like a big giant 1. Anything over itself equals 1. And it's being multiplied by these two things. It's being multiplied, not added to, but multiplied against these two things. So that's why I'm allowed to cancel it out. Because, like 5 over 5, that equals 1. Anything, even x plus 1 over x plus 1 equals 1. Anything over itself equals 1. That's what we call a giant 1. But the giant 1s have to multiply, not add. So this whole thing cancels out, it goes away, and we end up with x plus 3 over x minus 3. Okay, that's how you simplify these things. I don't know if you already knew that or if this is your first time learning about this, but they give you some kind of harder ones to factor, and I think there might be some of you who are still not really great at factoring. Don't use a quadratic equation on this because that's not going to give you the nice factors that you want. You have to learn how to factor if you don't already know. So this x squared has, see how this one just had a 1 in front of it? There's no number in front of x squared. This one has a 2, which means you're going to have to do your factoring a little differently. So the way I do it is I take these two numbers and I multiply them together and I get negative 20. So now I'm looking for something that multiplies to make negative 20 and adds to make the coefficient of x is negative 1. And then I realized that 4 times 5 is 20. Well, 4 times negative 5 would give me negative 20, and then when I add these two together, I get negative 1. So now I know that these are my two numbers that I want. Like, it's kind of like I'm splitting this x up, this negative 1x, into 4x and negative 5x, because those add up to negative 1x. And I'm putting it in this area model box. So I put my first term. I always do the upper left. I think some of you guys put your x squared down here, but it's still the same idea. I put this in the top left. I put my constant in the bottom right. I put my two numbers that I got from my diamond problem in the corners. It doesn't matter. I could have put the 4x here and the negative 5 here. It wouldn't matter. And then I remember that it's an area model, so something times something has to equal 2x squared. If I put the 2x over here, then I'm going to have difficulty over here because I won't be able to think of anything that times 2 equals 5. So it's best, I mean, really the only way I can situate this is where I have to put the 2x up here because 2x goes into 4. So this times this equals this. This times this equals this. This times this. I hope that you guys already knew how to do this, and this is just a review. Anyway, these are my two factors now. I can rewrite this as 2x minus 5 and x plus 2. Now I have factors. These were add-ins. These are all getting added or subtracted. There's 3 terms here. I need this to be factored, and now it is. The bottom, I also factored it. I said 3 times 2 was 6, and the coefficient here of x is 7. So I asked myself, what multiplies to make 6 and adds to make 7? And 6 times 1 works. So I did it. I put it in the area model box just like on the last problem. I put my 3x squared in the upper left, and I put my 2 in the lower right, and I put my 2 numbers that I found from the diamond problem in the diagonals, and then I asked myself, what times what equals 3x squared? I have to put the 3x above the 6 because if I put the 3x on the side, then I'm going to have an issue with this box right here. So that times that equals that. And then I say 3x times what equals 6x? Well, I answered myself 2. And then x times 1 is x, and 2 times 1 is 2. So these are my factors. So I wrote them here. And then I realized that I have, this is a giant 1 right here now. So I can just cancel this whole thing out, and I end up with 2x minus 5 over 3x plus 1. Okay, and then letter C, I don't know if you're going to have an issue with this or not, but even though these are add-ins, not factors, I'm thinking of it, I'm not thinking of it this way. Oh, 15 over 15, x over x. I'm not thinking of it that way. I'm thinking of it like this. Okay, since these are exactly the same. Anything over itself is 1. So the answer is 1. That's supposed to be a 1. The answer is 1. And then this last one, these are add-ins, and plus none of this stuff matches anyway. So I need to try to factor it to see if there's any cancellations. So I noticed that these 2 terms on the numerator have both an x. So I take an x out. See, this times this equals this. This times this equals this. I factored out an x on the top. The common factor on the denominator is 2, so I factored out a 2. And then I ended up with this giant 1. The giant 1 is x plus 4 over x plus 4, which I can cancel the whole thing out and get x over 2. So that's what you're supposed to take from this lesson, is that you need to remember how to factor if you don't remember how to factor, and then you need to cancel out the giant 1s.